So hello students, we'll continue again with unit number 1 and topic number 7, which is conventional slabs, modular construction methods for repetitive work, precast concrete construction methods, and conventional versus mechanized method of construction. So what do you understand by conventional slabs? The slab which is supported on beams and columns is called a conventional slab. In this kind, the thickness of the slab is small, whereas the depth of the beam is large, and load is transferred to beams and then to columns. It requires more form work when compared with the flat slab. In the conventional type of slab, there is no need for providing column caps. The thickness of conventional slab is 4 inches or 10 centimeter. 5 inches to 6 inches is recommended if the concrete will receive occasional heavy loads such as motor homes or garbage trucks. Conventional concrete slabs are square in shape and have a length of 4 meters. Reinforcement is provided in conventional slab, and the bars which are set in horizontal are called main reinforcement bars, and the bars which are set in vertical are called distribution bars. Based on the length and breadth of conventional slab, it is classified into two types. Number 1, one-way slab. Number 2, two-way slab. So what is one-way slab? One-way slab is supported by beams on the two opposite sides to carry the load along one direction. The ratio of longer span, that is denoted as I, to the shorter span, denoted as small b, is equal or greater than 2, considered as one-way slab. So in this type, the slab will bend in one direction, that is, in the direction along the shorter span. However, minimum reinforcement known as distribution steel is provided along the longer span above the main reinforcement to distribute the load uniformly and to resist temperature and shrinkage stresses. So the formula for one-way slab is longer span divided by shorter span is always greater than or equal to 2. In general, the length of the slab is 4 meter, but in one-way slab, one side length is 4 meter and the other side length is more than 4 meter. So it satisfies the above given equation. Main reinforcement is provided in shorter span and distribution reinforcement is provided in the longer span. So main bars are cranked to resist the formation of stresses. Your example. Generally, all the cantilever slabs are one-way slab. Chazzas and verandas are a practical example of one-way slab. Next, two-way slab. What is a two-way slab? It is supported by beams on all the four sides and the loads are carried by the supports along with both directions. In two-way slab, the ratio of longer span, that is I, to shorter span, that is B, is less than 2. The slabs are likely to bend along both the directions to the four supporting edges and hence distribution reinforcement is provided in both the directions. Hence, longer span divided by shorter span is equal to 1 by B, which is less than 2. So in this kind of slab, the length and breadth of the slab are more than 4 meters. To resist the formation of stresses, distribution bars are provided at both the ends in two-way slab. These types of slabs are used in constructing floors of multi-storied building. Modular construction methods for repetitive works. So, modular construction offers benefits such as high quality, low cost, and short durations owing to high productivity of repetitive production. To maximize productivity, modular construction involves repetitive schedules. However, the scheduling methods exhibit limitations when applied to on-site work. These methods are optimized by adjusting the production rate of activities. However, the bounds of the production rates of modular construction on-site work are limited because of workspace limitations in the units and varying amounts of work between the activities. This results in idling time in the scheduling methods. The modular construction method is excellent for projects involving repetitive construction work, that is, Construction of multiple structures of similar type. Examples are identical apartment blocks, retail outlets, educational buildings, sector-specific office buildings, etc. Since multiple modules of similar size, shape, and design can be built in the factory without many changes to the arrangements, it becomes even more convenient and economic. The next topic is precast concrete construction methods. A method of building a precast concrete construction includes lifting precast elements from a trailer load to the respective designated location via crane. It is convenient to establish precast yard and to erect the precast elements at near or the site, which speeds up the process and prevents delays in large-scale construction projects. Precast elements are being used for mass production to build a large number of buildings in a short duration. So this method is effective in terms of time, labor requirements, superior quality, better performance and finish, optimal material requirement, less wastage, desired shape, better finish, etc. So before selecting and finalizing the design of precast concrete structure, there are few points that needs to be considered, like what are the possibilities, restrictions, transport issues, and erection. Types of precast systems. There are four major types of precast systems which are classified based on load-bearing structure. Number one is large panel systems. Large panel system refers to the multi-story structures. In this type of structure, both large walls and floor concrete panels are connected in horizontal and vertical directions. These panels form a box-like structure with the capacity to withstand gravity loads. There are mainly three arrangements of the large panel system. Number one, cross-wall system. The main walls that resist gravity and later loads are placed in the short direction of the building. Number two, longitudinal wall system. The walls resisting gravity and lateral loads are placed in the longitudinal direction. Number three, two-way system. The walls are placed in both the direction. For apartments and hotel construction projects, this kind of system is used. Number two, frame system. In this type of structure, precast frames can be either linear elements or special beam column sub-assemblages. Linear elements are more preferred compared to beam column sub-assemblages because forming, handling, and erecting of special elements is difficult. The use of linear elements means placing the connecting faces at the beam column junction. Frame systems are being used for the construction of car parks, stadium, and offices. Number three, slab column system with shear. In this system, the slab column structure sustains the lateral load effect but resists the gravity loads. Below are the types in a sub-column system with a shear wall. Number one, lift slab system with walls. Here, the load-bearing structure consists of precast reinforced concrete columns and slabs which are assembled with spatial joints. Number two, pre-stressed slab column. Two pre-stressed columns are placed in orthogonal directions to achieve continuity. Number four, modular system. In this system, entire unit is cast in a factory and installed at the site, which is useful for smaller single units. This is suitable for toilet blocks and individual rooms, which guarantees waterproofing at junctions. Next topic is precast concrete construction procedure. So there are four processes involved in precast concrete construction. The first one is constructing a foundation for the building. Number two, erecting at least two vertical columns which can bear the load and reinforcing bars for the columns extending downwards. Number three, constructing a precast floor slab for the building in such a way that the floor slab is divided into modules, and these modules would be supported on two column forms, and also at least two column holes in each module and slab reinforcing steel extending through column holes in at least two directions. And the last one, after installation of precast concrete beams, precast concrete floors are erected. So, precast construction mainly includes those buildings where the majority of structural components are standardized and produced in plants in a location away from the building and then transported to the site of the assembly. Next, construction equipment basics. It is a new uh, it is a new topic or new part of Unit 1. So here, initially we'll start about conventional construction methods versus mechanized methods. So conventional construction methods means traditional method or traditional construction. So traditional construction refers to the techniques and methods employed for ages to build houses and other structures. In Canada, builders sometimes refer to conventional construction techniques as brick and mortar. Some contractors call traditional techniques stick by stick. So this term refers to the fact that traditional construction techniques from the initial design to the building process are hands-on. Foundation laid, walls constructed, roof addition, and at last the interior of the building starts. Finally, before giving it to the customer, the snag list is tackled and drawn up, all those small problems and tasks that are needed addressing. So only then is the building officially complete. So the materials required in traditional construction, a wide variety of materials and equipments are used in the traditional construction practices, from concrete floor slabs to brick walls. Concrete blocks are often used in building foundations or for load-bearing walls due to their high level of durability and strength. Similar to concrete blocks, a lightweight aerated block is available. Aerated block can also be utilized for building walls and foundations but have a higher level of cover. Next, modern or prefabricated construction or mechanized construction. Prefabricated, pre-finished volumetric construction (PPVC) is generally known as prefab construction and it is liable for such great achievements. So it is a construction technique whereby freestanding volumetric modules complete with finishes for floors, walls and ceilings are built and massed. Often these modern structures are constructed off-site in a factory where structural standards strongly implemented before the components are brought together for assembly and construction on-site. Prefab construction is becoming highly popular across the world. In Singapore, demand for prefab is more rampant than before alongside mass-engineered timber. Prefab structures can vary from towering structures to simple one-family houses. Pros of traditional construction versus modern construction. The advantage of traditional construction methods, particularly in housing construction, but also in industrial buildings, is the level of singularity accomplished. When dealing with an architect, a consumer has the choice and freedom to modify the architect, also has the opportunity to be creative. So with the utilization of more modern construction methods, most homes are in the same style. So in the case of modern homes, the components are fabricated at a factory to use on site quickly. The use of traditional home renovation in Toronto often results in a stouter home of higher quality is such an example. Cons of traditional construction versus modern construction. The cons of using traditional techniques of construction for housing and other building is that the process takes a very long time. The construction process is more entangled and can demand hiring highly skilled builders and designers. It can add significant construction costs, materials and labors are more expensive. So advantages of mechanized methods. Smaller demands on facilities and equipment construction site, safer working environment at the offsite production of building components, faster construction over labor costs. The possibility of using state budget funds, special purpose funds or foundations. Fewer design errors and better quality in the manufacturing of components, easier quality control at the factory, less water waste on the construction site and less environmental pollution during construction, easier quality control at the factory, less waste on construction site and less environmental pollution during construction. So that's all. Now you can give your attendance with your name and enrollment ID in the chat box. Also we'll go through 2 to 3 videos if time permits and if the meeting doesn't end. And even if it ends, we'll continue with those videos in our next class. So that's all for this lecture. Thank you.
cast concrete and cast in situ concrete. So let's start. Method. Precast concrete is the new method of concreting which is used all over the world extensively. It is also used in India as well, but not very often. In precast concrete method, concrete is made, poured in reusable mold, cured in a controlled environment, transported to site and lifted into place. Here controlled environment is nothing but a precast plant. Cast in situ concrete, also known as cast in place concrete. It is the conventional method of concreting. This method is generally used in India for most of the projects. In this method, formwork is made at site and liquid concrete is poured in the formwork and then cured. Precast concrete members are casted and cured at precast plant and then transported to site, and only jointing will be done at site. Whereas the cast in situ concrete is casted at site and cured at site. Casting. In case of precast concrete method, elements like slabs, beams, columns can be casted in advance, thus it saves time. Whereas in case of cast in situ concrete method, elements cannot be casted in advance. Quality. In case of precast concrete, quality can be controlled and maintained easily because precast concrete is made in a factory, hence ideal conditions and exact measurements can be maintained throughout the process. Precast concrete gives better quality than cast in situ concrete in terms of durability, stability and reliability. Water cement ratio can be properly adopted in precast concrete than in cast in situ concrete, which can lead to better quality control. Whereas cast in situ concrete is casted at site, hence quality is concerned with workmanship. Many times the cement slurry flows through the badly fitted formwork, which can lead to poor quality concrete. Labors. In precast concrete method, less number of labor shall be required, as only joining of members shall be done at site, and also less skilled laborers are required for this job. Hence labor cost can be saved. For cast in situ method, more number of laborers shall be required, as all the works like pouring, mixing, shuttering, deshuttering, curing shall be done at site. And also for these works, more skilled labor shall be required. Speed of construction. Precast concrete method requires less time for on-site construction as compared to cast in situ concrete method, because precast members are transported to site and can be directly lifted and placed on desired position, and there is no waiting for it to gain strength. It requires minimal propping and bracing, hence it speeds up the construction time and saves cost. Whereas cast in situ method of concreting requires more time, because concrete requires minimum 28 days to achieve 99% strength of its total strength. Thus, after creating one element, only after 7 days a new element can be created, which is dependent on previous one, because concrete achieves 65% strength of its total strength in 7 days. Curing conditions. In construction industry, curing takes major time in project completion. In precast concrete method, curing conditions can be controlled in a factory and high early strength can be achieved with the help of accelerated curing. The most commonly adopted curing techniques
Grammarly helps you do this.
are steam curing at atmospheric pressure, warm water curing, boiling water curing, and autoclaving. Hence, there is no need of curing on site after erection of members, as members are already cured in factory for desired days. Precast members can be installed immediately with no need of waiting for it to gain strength and modularity like cast in place. Therefore, it saves time and also reduces the cost of construction. Whereas, in case of cast in place concrete, accelerated curing is a difficult task and also it's not worth. Hence, you will have to wait until the curing period gets completed. This increases the time of construction. In construction industry, time is directly proportional to cost, hence cost also increases. Weather condition. In case of precast concrete, weather condition has no effect on casting work. A fabrication site for precast concrete can operate regardless of the weather. Precast concrete doesn't shrink, distort or move and does not deteriorate with exposure to climatic change. Suppose if it is raining and your precast slabs arrive on site, then you can simply lift them into place. Whereas in case of cast in place concrete, unexpected weather conditions can delay the casting work, and if concreting is happening in cold weather, then it can add cure time. Cost. In case of precast concrete construction, similar types of components are produced fast, resulting in increased productivity and economy in cost too, thereby reducing the time period of construction, which can be beneficial in early returns of the investment. In precast construction, you can save the cost of on-site shuttering and de-shuttering. It requires less number of labors, hence you can save the cost of labors too. In precast construction, pre-stressing is done, hence it requires less reinforcement as compared to cast in situ concrete. As per research article published in Journal of Construction Engineering, on an average, the precast concrete slabs are 23.22% cheaper and precast columns are 21.4% cheaper than in cast-in-place concrete construction, especially for large-scale production. Whereas in situ concrete is cheaper form of construction for small structures. The shuttering and de-shuttering takes more time and space and hence increases cost of construction. Standardization and repetition. In case of precast method, for repeated similar pieces like walls on a high-rise building, there is greater potential for standardization and repetition. The mold for the precast components can be used for large number of repetitions, thereby reducing the cost of mold per unit. Whereas in case of cast in situ concrete, the repetitions of shuttering are very less as compared to precast. So if limited standardization and repetition occurs, then cast in situ method will be more beneficial. Handling. Precast concrete requires heavy machinery and cranes for handling, that is lifting and installation of heavy elements. In case of cast in situ concrete method, the construction can be done without cranes. Number of joints. In case of precast concrete, there are large number of joints in structural system. In precast concrete construction, details at the joint become very critical and needs careful attention. Whereas in case of cast in situ concrete, less number of joints will be present in structural system and no serious attention is required for joints. Resistance to earthquake. Precast concrete members are less resistant to earthquake and wind forces, hence they are not recommended where seismic loads are dominant. Whereas cast in situ concrete members are more resistant to earthquake and wind forces. Contractor. To construct precast concrete structure, one needs